Hello, and welcome to this short video on polygons. This is Brett Etheridge with Dominate the GMAT, and I'd like to teach you a really cool shortcut, a trick that's going to enable you to find the sum of the interior angles of a polygon much more quickly than you may currently know how to do. And it's one of these little tricks that's not only going to save you time on the GMAT, it's something you're going to remember forever, whether that's useful or not. Now, as you know, sometimes questions are going to ask you maybe to find a missing angle, for example. So maybe you're asked to find x, and maybe this is connected to some other figure. And answering the question is going to require you to know the sum of the interior angles, because without knowing the sum, it'll be hard for you to solve for that missing angle. Now, a lot of times books will give you that annoying formula. The sum of the interior angles is n minus 2 times 180, where n equals the number of sides of the polygon, blah, 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 blah. As you know, I don't like to memorize formulas, and there's a much faster way to learn how to do it. And it starts with remembering that what is the sum of the interior angles of a triangle? 180, right? We know that. We know that the sum of the interior angles of a triangle are 180, and that's going to become useful when we're looking at polygons of more than 3 sides or 4 sides as well, right? Because what's the sum of the interior angles of a quadrilateral, right? If it's a simple rectangle, for example, it's easy. That sums to 360. Right? And so a lot of times when it becomes difficult is when we have a 5-sided figure, as we have here, called a pentagon, an 8-sided figure called an octagon, or a 6-sided figure, for example, called a hexagon. And how do we figure that out? Well, we could memorize a table, or we could memorize this formula, or let's look at this cool little trick. So basically, all it requires you to do is pick one of the vertices, which is one of the points where 2 lines come together, a vertex, one of the vertices of the polygon, and simply create the fewest number of triangles you can by drawing a line from that vertex to the other vertices. Very, very simple, right? Well, it doesn't do us any good to draw a line down here because that doesn't create a triangle. But if we draw a line here, that creates a triangle. If we draw a line to the next vertex, it creates another triangle. Ah, there we go. We have 3 total triangles. Now, what is the sum of the interior angles of one triangle? 180. How about the next one? 180. How about the next one? 180. So literally all we've done is we've said, okay, how many triangles do we have? And what's the sum of the angles of each of those triangles? Ah, there we go. And that's going to equal 540. Much simpler, isn't it? And it works with all of them. Let's take a look at this octagon, right? Pick a vertex. We'll start here. How many triangles can we create? Well, we can draw a line here, that's 1. We can draw a line there, that's 2. We can draw a line here, that's 3. And you can literally do this on your scratch paper on test day. I mean, they could give you a 13-sided figure. Well, you don't want to have to memorize that, but you can do the same thing. Let's draw triangles. Let's draw from one vertex to the other vertices. And how many do we have here? We have 1, 2, 3, 4, 5, 6 triangles. So what we have to do is 180 times 6. Now, it might be a little bit annoying, right? We don't necessarily have that math memorized, but the math becomes easy. 6 times 8 is 48. Carry the 4, that's 10. 180, or 1,080 degrees are the total for the sum of the interior angles of a polygon. And finally, we can do it with the hexagon. We have 1, 2, 3 lines. So we have 1, 2, 3, 4, 4 triangles, and so 180 times 4 is going to equal 720. And there you go. Very simple, very straightforward, cool shortcut. Now, one other thing to say, these are regular polygons, but what you have to understand is the sum of the interior angles is going to be the same regardless of how the figure looks. Any 5-sided figure, for example, let me draw a little figure up here, right? Let's say I had a convex polygon that looked like this, right? How many sides does that have? Well, it still has 1, 2, 3, 4, 5 sides. So are the interior angles going to be any different than what we saw here with this regular polygon or this regular pentagon? No. It's just that one of those interior angles is actually going to be really large. Like that might be 240 degrees, but as a result, this angle might have only been, I don't know, 40 degrees. And this angle over here might have only been 40 degrees. The point is the sum of all of those plus that one are still going to equal 540 degrees. So just kind of keep that in the back of your mind. When you're dealing with a polygon, count the number of sides, and if it's obvious like this, you can use the vertex shortcut here. You wouldn't want to do that shortcut because you don't have vertices to be able to draw to, but you can still recognize that as long as it's a 5-sided figure, you can redraw it if you want. You figure out that the total's 540 degrees, and you still get the same outcome. So I hope you think this trick is pretty cool. I think it'll save you time on test day. It'll certainly ensure that you don't have to spend your time studying for the GMAT, memorizing formulas like this, or worse, memorizing tables of different polygon number of side figures. And I think it's just going to make your life a whole lot easier. So internalize this trick. You'll never forget it. And I know it'll serve you well for getting more right answers to go out and dominate the GMAT.